Helical strakes are one of the most common solutions to address structure vibrations. They consist of thin fins that wrap around the stack in a circular shape. These fins cut through the wind, disrupting possible vortex shedding. Using strakes do have some disadvantages and limitations, and so please refer to articles on our website for more discussion on strakes. In the damping selection drop-down, pick Helical Strakes, then select Click for details below. Top elevation of the strakes is where the top of the strakes are located, while the bottom elevation of the strakes is where the bottom of the strakes are located. It is recommended that the strakes cover the top 1/3 of the stack. The shaped factor that is to be used on the bare stack diameter, which is typically 1.4. Please note that some standards or specifications refer to a value of 1.2. However, typically this value is used when considering the straked width of the stack, not the bare diameter. A 1.2 factor on the straked region is equivalent to a 1.4 factor on the bare diameter, and since MecaStack uses the bare stack diameter, we recommend a value of 1.4 be specified here. Thickness of strakes determines how thick the strakes are. Radially width of the strake protruding from the shell, this is recommended to be 10% of the stack diameter. The strake pitch represent the vertical height of stack that it takes to complete one complete strake wrapping 360 degrees around the stack. It is recommended that the pitch be 5 times the stack diameter. Strake standoff decided the gap between strakes if applicable. This would be used if there is insulation or clips that have the strake not directly adjacent to the stack outer diameter. Clicking the standard button at the bottom will populate all of these values with the recommended values. Typically, you would click this button first and then modify the values if needed. MecaStack application assumes that the designer knew what they were doing and that the strakes are solving the vortex shedding. Unless the Euro code is selected, no other code gives a basis for analyzing vortex shedding when helical strakes are present. Some standards do say that if you encounter a flange or stiffening ring, that you stop the strake on one side of the ring and then start it on the other side. There are countless other real-world situations that require users to deviate from the recommended values. If you deviate from the recommended values, the software has no way to determine if those deviations are acceptable or unacceptable. Most of these deviations will require you to exercise engineering judgment because there is no calculation you can perform to tell you if the deviation will negatively impact the performance of the strakes.